Hi everyone. So we are going to continue with polynomial operations here in chapter 9 for algebra 2. And all of these operations today focus on division in some way. And remember that division often appears like a fraction. Okay, so we're going to be doing a lot of fraction work today. I've put together these examples here just to kind of remind you about some basic things about fractions. I think instead of working through all of those together at the beginning, I'm going to just dive into the examples, and then when we hit something where I want to make a point using, some basic fractions, we'll come back to these. Okay, so I'm going to start right away with this dividing by a monomial. Okay, so notice that in these problems, you've got some complex polynomial happening up here at the top, and then just a single term down here at the bottom. This process is going to change a little bit if there's more than one term on the bottom. But for right now, we're just looking at ones where we've got a monomial downstairs. Okay. What I want to remind you is that when you have a problem arranged like this, and I don't know if you've ever seen one with this many variables before, but you're familiar with this concept, that really what this means is each item from the top, and this is going to take me a second to write out, is being divided by that denominator. So we have that plus the 16 ab to the third over 2ab squared, and then minus the 10 a cubed b squared over 2ab squared. Now, I'm not suggesting every time you have to take the time to write that out that way, okay? But I want to really drive the point home that when we say we're dividing this thing by that denominator, each one of these pieces needs to get divided by that denominator, okay? So when I do that, remember that the numbers themselves, so like in this first example, the 8 and the 2, in this example, the 16 and the 2, and then here the 10 and the 2, those regular numbers are going to work the same way regular numbers do. This is a division problem, so we're going to divide them, okay? But the exponents work a little differently. The exponents, when you divide with powers, you subtract the exponents. And that's what this example was meant to show you. I don't know. Well, I guess there is one thing I should show you here. So let's take a look at this example real quick, and then we'll circle back to this. So like we just said, when you're dividing with powers, you subtract the exponents. So this would give me a to the first power. Okay, 4 minus 3 is 1. Now, when you go to do 7 minus 10, you get a negative 3. Okay, we don't want to leave it as a negative 3. What that negative 3 is indicating is that the b would really live on the bottom of the fraction. And if you think about this, if you had 7 b's on the top and 10 on the bottom and you went through and canceled them out, the 3 that were left over would be left over on the bottom because there's more down there. So that negative exponent piece kind of gives you an indication of where you should leave your variables. I don't know if that's going to happen in this example or not, but just want to make sure we talk about it. So with this one, 8 divided by 2 is 4. And then I'm going to take each one of these and subtract an a. So I'm going to go a to the fourth minus a to the first would be a to the third. And then here, 6 minus 2 is 4, so that'd be b to the fourth. 16 divided by 2 is 8. And again, I keep emphasizing that you're dividing those numbers because I see people want to subtract them because you're subtracting all these exponents. Remember, these numbers work like regular numbers. So here I have an a over an a, so really those just cancel each other out. 1 minus 1 would give me 0, and then 3 minus 2 gives me just 1b, minus 10 divided by 2 is 5, 3 minus 1 gives me 2, so I have an a squared, and then the same situation as the a's back here, in this one my b's are going to cancel. So this thing would be my final answer. Okay. So when I look at that next one, I've got this giant mess being divided by just a single y. Essentially, all that's going to do is knock a y off of each of these terms. Just remember to do it to each one. So I don't think I need to take the time to write it out the long way here. I think we can just say 7x squared y to the fourth minus 4xy to the fifth plus x to the fourth and then a single y. Okay, So reducing fractions, really something like this we've already kind of talked about. This is similar to like all of these. We were reducing fractions here. So this shouldn't be too bad. So I'm going to go 21 with the 3, the x with the x, the y with the y, the z with the z. 21 divided by 3 is 7. I have 5 minus 1, so that's going to give me an x to the 4th. 7 minus 4 gives me a 3, so I have y cubed. And here we run into our first negative exponent. 2 minus 8 gives me negative 6. So that means the leftover z's are going to be on the bottom of the fraction. So underneath this thing that I just came up with, I'm going to have z to the 6th power. Okay, we've got some multiplying of fractions happening here. So I want to remind you of a couple of things. So when you are multiplying fractions, let's take a look here. You really are just multiplying top by top and bottom by bottom. So if I wanted to, I could go 2 times 3 is 6, and 3 times 5 is 15. But then I need to reduce this thing. And remember, reducing is where you divide them both by the same number. You figure out what can go into both of them. In this case, both of those things could be divided by 3. And so I would go 6 divided by 3 is 2. 15 divided by 3 is 5. And so my final answer here would be 2/5. But I also want to point out that, and I don't know if you learned this shortcut back when you first learned fractions, but if you have numbers that are across from each other, I mean, we know this 3 is going to be up on the top, and we know this 3 is going to be down on the bottom. Those numbers can cancel each other out right at the beginning. You know, I can say, well, this 3 and this 3 are going to end up crossing each other out, and then look at what I'm left with. I'm left with just a 2 and a 5, okay? If they gave you something more complex, if they gave you something with, let's say, a 2/9 times a 6/4, let's say. I don't have any that can cross out. I mean, I don't have any that are identical to each other, but I can reduce them. So, like, for example, 2 and 4 can both be divided by 2. So I can do that. I can say, well, I'm going to divide this by 2 and make it a 1. I'm going to divide 4 by 2 and make it a 2. Okay. 6 and 9 can both be divided by 3. So 6 divided by 3 gives me 2. And 9 divided by 3 gives me 3. And then the nice thing about this is going to make our multiplication much easier at this point. Okay, I can just multiply straight across here and here. So 1 times 2 is 2. 3 times 2 is 6. And actually, I ended up with one that still could be reduced after that. This would be a 1/3. And if I had caught this back here, that I had a 2 over a 2, I could have canceled those things out, you know, back in that step. I didn't notice that at the time. But what I'm trying to point out to you, when we start getting into all these ones that have X's and Y's and stuff like that on the tops and bottoms, anything on the top can cancel with anything on the bottom, or reduce with anything on the bottom if they can't cancel all the way out. And if you do as much reducing ahead of time as you can, it's going to make your final answer much, much easier to simplify. Okay, so all of that being said, let's take a look at this next example. If I wanted to, I could dive right in and start multiplying the top together and multiplying the bottom together. And I'm going to get some big messy fraction here. And then I could go through and start doing all of my reducing up and down. And if you like that, more power to you. You know, feel free to do that. But I usually like to kind of reduce things a little bit first. And I'm going to blow this up so that hopefully you can see what I'm doing here. So for example, I look at this and I see a 14 and a 12. Both of those can be reduced by a factor of 2. They can both be divided by 2. So let me do that. I'm going to make this a 7, and I'm going to make this a 6. Okay? Important to give yourself plenty of space to do this. Then I see an m to the 4th here and an m here. So I know that eventually I'm going to end up doing m to the 4th divided by m, which will drop this down to a power of 3. And it's going to get rid of this m altogether. Here I've got an n and an n squared. I know if I have one n on top and two n's on the bottom, that one n will cancel and I'll be left with just a single n. It's really like an n to the first power down on the bottom. Okay, hopefully that's making sense how I'm kind of plowing through that. Now let's go with our other diagonal. 6 and 3 can both be divided by 3. So if I divide by 3, this becomes a 2 and this becomes a 1. I've got a to the 8th with a to the 3rd. So if I do my subtraction, 8 minus 3 leaves me with 5. That's really canceling out these 3 and turning this one into a 5. And then this b doesn't have anything to combine with. So now let's go through and see what's left. And then we'll check our answer and see if it needs to be reduced farther. So as far as just regular numbers go, the 7 and the 2 are remaining, right? So on the top here, I'm going to have a 14. I've got an m to the 3rd and an a to the 5th. And I can't really combine those at all. I'm going to put the a first, just because, like I said, I always try to do this alphabetically. Wouldn't be wrong if you did it the other way. Over, and on the bottom, 1, I have a 1 and a 6. So I'm going to have a 6 here. My a cubed is gone. I've got a b squared and an n. Okay, so I did almost all of my reducing ahead of time. It looks like I do have one little piece that can still be reduced further, this 14 and the 6. I can divide those both by 2, so this would give me a 7, and this would give me a 3. And so then I should rewrite my answer with those. So 7, a to the 5th, m cubed over 6, b, oh, sorry, not 6, 3. 3b squared n. And the only reason I had this other step to do at the end is I didn't catch when we were doing our problem originally that we had a 2 and a 6 on top of one another. Okay, I was focused on those diagonals, but I didn't notice the 2 and the 6. I could have gone in here and said, all right, let's reduce those now. Divide those both by 2, and this becomes a 1, this becomes a 3, and then we would have jumped straight to this answer. Okay, so just keep in mind, anything on the top can cancel with anything on the bottom. Now, we spent a ton of time on that, and that's important. I mean, you're going to see a lot of those. That same process does not work for these next two examples, okay? I want you to notice here that you've got addition and subtraction, meaning you've got multiple terms. And the one thing that I'm hoping you'll walk away after this lesson with is this idea that a single term works much differently than multiple terms, okay? I cannot, and I can't even emphasize this enough, I cannot come in here and start canceling out these y's or canceling out these x's or reducing the 2 and the 6 because these things are connected with addition that has to be done before you do any division. And you can't divide to cancel out addition. So right now, I can't do anything the way these things are written. The only way I can cancel things out is if I'm looking at multiplication. If I have like something times something, then I can do some division to cancel that out. So I'm going to do a process called factoring, and we're going to do much more factoring later this year, but these are pretty simple factoring ones. I'm going to look for what these things have in common. Now up on the top here, x and 2y don't have any factors in common, so I can't really do anything with that. But let's look down here on the bottom. 3x and 6y, each one of those could be divided by 3. Now, I can't just cancel that. I can't just say, oh, look, I can divide by 3 and change my answer here. But what I can do is I can do almost like the reverse distributive property. I can put that 3 on the outside of a set of parentheses and then say what's left over. So this would be left with an x, and then 6 over 3 would leave me with a 2y. So if I distributed this 3 back in there, I would get that original thing back. So I didn't get rid of the 3, I just moved it to the outside. The reason that's important is if I think about this being in parentheses and this parenthesis here, notice that that whole parenthesis matches, and I've got multiplication here, which means I am allowed to cancel this whole thing with this whole thing, because now I'm using division to cancel the multiplication, okay? And that is allowed. As far as my final answer goes, keep in mind there's a 1 sitting up here. So my final answer here would just reduce to 1/3. So now let's do something similar with this next one. Think about what the 3x and the 9y have in common. They can both be divided by 3. Okay, so I can take a 3 out, and then let's say what would be left over from the 3x, I would just have an x. 9 divided by 3 would be 3, so this would be minus 3y. Over, on the bottom, 6m and 12n could both be divided by 6. So I'm going to put the 6 out front, and then I'm going to have an m plus 2n. Now in this one, my parentheses don't match, right? I don't have the same situation I had up here. So there is absolutely nothing I can do with these values. But I can look at this thing, 3 over 6. Okay, and I can say, well, I know that 3 over 6 reduces to 1/2. So I could make this and technically you wouldn't need this 1 here, but I'm just making a point. Over, and then on the bottom, this would be a 2m plus 2n. That one hardly seems worth the amount of work that it took just to reduce a 3 and a 6 down to a 1 and a 2. But if that's the goal, if your goal is to reduce it as far as you can, this is where you would want to go as far as an answer goes. Okay, that was kind of a lot. There is more to come in this section, but I'm going to leave that be for now. If you wanted to try a few of these in your homework before moving on to the second half of the lesson, you could. But do keep in mind there is a second video that goes along with this lesson. Please make sure you get that done so you can complete your assignment.